Okay, so I've been working on the file format side of sound stuff. Now I want to switch over and do some sound generative work. This is kind of a creative, explorative thing. This is not something I've done a lot of before, so I'm going to be learning as I go, just like I did with the file format. But unlike the file format, I'm not learning about a spec, rather I'm learning a topic and how to write code for it. So we're going to be playing with some things where I don't exactly know the best, algorithms that exist for a certain thing. I don't know the ways that certain effects get created, and I'm going to be trying to learn that and figure out what I can through experimentation and through research. So the place I want to get started is I know a little bit about sound, so I know enough to know that I want to be able to create different shapes of signals, control frequency over time, so I want to be able to do pitch bending, modulating volume and pan, those kinds of things, and I want to figure out good ways of expressing that. I also want to then have a system for mixing multiple signals together, which basically means adding them together. But I want to look at the issue of trying to avoid having that clip. So maybe introducing compressors there, or maybe determining that just capping, using a clamp is the best thing to do. I don't know what I'll decide to do there exactly, but I want to look into thinking about that a little bit more, think about the different techniques that I could think of and what I can find in research, and try to get something good so that I can compose more complex sounds out of multiple signal generators, something like that. So that's what we'll start with today. I'm going to see if we can get through those ideas, and maybe by the end of today, hopefully have some more clear ideas on what would be the next more ambitious things to try after these basics. So let's get into it. Okay, so I'm able to generate waves with different shapes. I got sine waves, square waves, saw waves, triangle waves. I even played around with squaring the sine wave. Uh, I thought that might be interesting. I was curious what that might sound like. Here it is, if you're curious. I think the most interesting part here is working out how the loop should be set up. The main thing that was an issue is that if I just have a time value that I'm using to build samples with, and that time value is just growing and growing, the sine function for building the sine wave doesn't keep up. It doesn't give good sample values after a little while. If you take a listen to the 100-second sine wave, after a few seconds here, I think I started in about 15 seconds in, it starts to degrade the sound of the wave a little bit. And then a little bit later, you can tell it's getting worse and worse as time goes on. The wave just gets less and less crisp sounding. So to fix that, what I did is instead of tracking the full time value, I decided that since I'm generating these sort of oscillator sounds right now that are all based on a periodic wave, I only really need an input to the function that generates the samples that is in the range from 0 to 1, right? And then I just will have that repeat over and over again. So at 440 hertz, that means 440 times per second, that parameter is ranging from 0 to 1 and then looping back to 0. Then there can't be any amount of drift. I'm literally keeping it as close as possible. I'm multiplying by 2 pi or tau in the loop because I'm trying to get it into the range that sine will understand. But besides that, nothing is taking it outside of that range from 0 to 1 before I send it to the sine function. So it's as close to 0 as I can get while still actually getting the correct values back, roughly speaking, right? So I think that that's a good way to do it. There might be a smarter way to do it if I were to sort of think through the exact number of samples that it's going to take to get to a period, and then, I could just copy paste that over and over again and only generate the period once or something. There might be smarter stuff I should be doing there, but that seemed like a good way to get it in there, and I was able to work out all of the formulas based on this idea of mapping a function from 0 to 1 to a sample value, which is from -1 to 1. So that's what all the other functions here ended up being phrased as. So next, what I want to try to do is to bend pitch and modulate volume in pan as a function of time. All right, that was pretty fun. I didn't end up with a whole lot of new code, but that's not really the point with something like this. For now, I'm just sort of playing around with it, gathering insights about how certain things work, getting my head around things. So, for instance, I picked up on this pattern of how I'm going to probably be doing lots of these periodic functions within each other. So I have one segment or one variable that's getting updated at a certain frequency and another variable getting updated at a different frequency, and they're sort of controlling each other or interacting in interesting ways. That seems like a pattern I'm going to want to build out as I'm doing this stuff. I also got to see that my frequency modulation is pretty easy this way. I didn't have to change the way I was doing the loop. I could just update the frequency every step of the loop, and it made a pretty good pitch bend. Here's my favorite of the pitch bends I played with. I called it Scoop, and the way it works is it increases the frequency by taking the square of t over a range, so that as you get closer to the end of the range, your frequency shift gets closer, it grows more quickly like a parabola in the range from 0 to 1. The other ones that I made that I liked are just modulating the volume based on a beat, a sine wave that has a frequency of 3. It creates just sort of a little pulse sound. And then I tried using Euclidean distance and a set of points to create a pan effect so that you can hear something more loudly on one side than the other as a point moves around. It's not really great yet. I think I need to spend more time working on this in particular if I want to get this kind of effect to work, but you can at least tell the pan is working in this sample. Now I want to wrap up by looking at mixing multiple signals and doing some kind of compression to deal with possible clipping that would come from two signals adding to an amount that goes beyond the limit of our, -1 to 1 range. Alright, so at this point I tried a lot of different ways to mix signals together and compress them into the range -1 to 1. I think the easiest, sort of most trivial two ideas that I tried were just clamping to the range -1 to 1 and dividing by the number of signals. The reason the clamping works is obvious, it just doesn't let it go outside of -1 to 1. The divide works because, if I have n input samples that are all in the range from -1 to 1, when I add them together, the largest range that can span is -n to +n, so divide by n definitely puts it inside the range. Here's what the clamp sounds like. That, I think, is pretty clearly showing the signs of the clipping. You can hear it sort of getting that squarish shape, and it's not so smooth in the sound. Here's the divide by n sound. So I think that second one sounds a lot better. It's just clearly quiet too, which I think is the main issue with simply dividing by n, is that it ends up making everything sound quieter than what it sounded like when it was a signal by itself. You very quickly make everything quiet when you're mixing just a few signals that way. So I went on to try a bunch of other things. Let's take a look at a couple of those ideas. I think the most interesting thing I was looking into was several different shapes of S-curve, where the idea of an S-curve is that it's at 0 and it kind of looks like a straight line around 0, but then it approaches 1 or -1 as it grows out towards infinity. So I thought those might be an interesting way to do this. So I tried out two different S-curves that are pretty easy to put in. The first one is the inverse tangent. Here's what that sounded like. And I also tried a sigmoid function. The exact formula for that is on the screen here. It's just a function that uses a couple of ideas of inverse function, like reciprocal functions and exponential functions, to map the range from -1 to 1 into the range, to map the range from -infinity to +infinity down to the range from -1 to +1. So here's what that sounded like. I also tried just using a sharp thresholding function. So after the strength of the signal gets above a certain level, it just automatically kicks in this threshold and shrinks it down to within the range between the threshold and the top level. So for instance, if I'm mixing two signals, I might say that above 0.5, I take the range from 0.5 to 2 and I shrink that down to the range 0.5 to 1. So I'm decreasing the values above a certain threshold so that those values will not go past 1. And then the values that are close to 0, I leave them exactly as they are. And here's what that sounded like. I think of all of them, the divide by n still just clearly sounds the best. I think that threshold, especially the one I played for you, when I did a little bit more than just threshold there. I did a threshold and I also divided the signal a little bit, like fairly close to dividing by n, but not quite all the way divided by n. So that gives me like a parameter to tune how much distortion I would get versus how much volume, like, degrading I would get. And it seemed like if I put that around 0.96, 0.97, I'd get a sound that was a little bit louder in quality than the divide by n, but very, very low in distortion as well. So I have a couple options there of things that I really like. It seems to me like when I'm mixing generated signals that are already generated at full volume, the best move is to just divide by n, but maybe the better move will be to avoid signals that are at full strength to begin with, and as I start putting in a lot more dynamics in the generation of things, it might make more sense to apply one of the other compressors. So I've got a bunch of these options. I know what they do, and I can work with this, so that's a pretty good place to stop for today. I've done a good exploration of these ideas, and next time I'm going to get into building up a little bit more machinery that I could use to craft a sound intentionally. So I'll see you then.